Hello everyone. Please use this video in tandem with today's notes, as it will go through each of the exercises, the breakdown, the how to do them, so on and so forth. It's just that in the notes for today, the space to work the problems isn't that large, and so I wanted to do a video that has more space, fully explained, nice and legible problems, etc., etc. All right, problem 1, the hilltop. The angle of elevation from point A to the top of the hill is 49 degrees. If point A is 400 feet from the base of the hill, how high is the hill? So I have my known measurement, my known angle of 49 degrees. I know I'm 400 feet away from the hill, and I want to find my height of the hill. So to put this in trigonometry terms, I have a theta. I know my adjacent, and I'm looking for the x, which is also my opposite side. The trigonometric ratio that we're going to use for this is TOA, or the tangent of our angle of 49 is equal to the opposite, the x, divided by 400, our adjacent side. I want to isolate my x, so I'm going to multiply both sides by 400. 400 times the tangent of 49 is equal to x. Therefore, x is approximately equal to 460 feet. Problem 2, the sun. We want to find the angle of elevation of the sun when a 12.5 meter tall telephone pole casts an 18 meter long shadow. So in this case, we're looking for this angle here of theta that we don't know, but we do have an opposite side to it and an adjacent side to it. This is going to be another tangent situation, or another TOA situation, such that the tangent of theta is equal to my opposite side of 12.5 divided by my adjacent side of 18 meters. Now, to isolate this unknown theta, this unknown angle, I'm going to use my inverse tangent from last week, such that my inverse tangent of my tangent of theta is equal to my inverse tangent of my 12.5 over 18. Inverse tangent and tangent cancel out. So theta is equal to the inverse tangent of 12.5 divided by 18, which means that it's approximately equal to 35 degrees. Skiing. A ski run is 1,000 yards long, has a vertical drop of 208 yards. We want to find the angle of depression from the top of the ski run to the bottom. So there are two ways to solve this problem, and I'll work out both of them for you. Method 1 involves thinking back to parallel lines and transversals, a topic that we talked about way back in October. If we have two parallel lines that are cut by a transversal, then we have pairs of angles that are congruent to each other. Let's say that angle there would be congruent to that angle there. So this angle that's unknown, this question mark, which I'm going to call red theta, is actually the same measurement as this angle down here of red theta. So we could solve this in terms of red theta. If we do that, then our 208 is opposite the angle, and the 1,000, well, that's my hypotenuse. So opposite and hypotenuse trig function is going to be my SO, or my sine function. So the sine of my theta is equal to my opposite of 208 divided by my hypotenuse of 1,000. I want to isolate that theta, so I'm going to use my inverse sine from last week. So the inverse sine of sine theta is equal to the inverse sine of my 208 divided by my 1,000. Inverse sine and sine cancel out, leaving me with theta is approximately equal to 12 degrees. The other way we can work it is if we think about it, this horizontal line here and this vertical line form a right angle up here, such that, let's see, different color, brown. This brown theta plus this red theta must equal 90. So brown theta plus red theta must equal 90 degrees. So if I solve for whatever the brown theta is, I can then subtract that answer from 90 to find my red theta. And how that's going to look like, divide up the space here so I don't get things mixed up. In terms of my brown theta, my 208 is my adjacent side, and my 1,000 is still my hypotenuse. So instead of a sine function, we're going to be dealing with a cosine function. The cosine of brown theta is equal to my adjacent side of 208 divided by 1,000. We'll use our inverse cosine function to rewrite our equation as theta is equal to the inverse cosine of 208 divided by 1,000. Plug that into our calculator. Theta is equal to 78. And then 90 minus 78 is equal to our red theta of 12 degrees. Either way works. I prefer this method, but if you prefer this method, feel free to use that method for angles of depression. Air traffic. Another angle of depression problem. So again, there are two ways we can work this out. From the top of a 120-foot high tower, air traffic controller observes an airplane on a runway at an angle of depression of 19 degrees. How far from the base of the tower is the airplane? Well, if that's 19 up there, that means this right here is also 19 degrees. And if that's 19 degrees, then this 120 is going to be my opposite. And I'm looking for my adjacent side. Therefore, this is going to be a tangent situation. The tangent of 19 degrees is equal to my opposite of 120 divided by my unknown value, the adjacent. I'm going to multiply both sides by x. So x times the tangent of 19 degrees is equal to 120. Now I'm going to divide both sides by the tangent of 19 to isolate my x. So x is equal to 120 divided by the tangent of 19, which will give me approximately 348.5. The other way to solve it? Well, if this is 19 And this here must be 71. Because 19 plus 71 equals 90 degrees. Therefore, if that's 71 up there, this 120 is actually my adjacent side, and this unknown value is actually my opposite side. So I could solve it out by saying the tangent of 71 is equal to my opposite of x divided by my adjacent of 120. Multiply both sides by 120. 120 times the tangent of 71 is equal to x. X is approximately equal to 348.5. Two ways, we still get the same answer. All right, so this next problem. This problem, the next one, are the ones I asked for you to do on your own and check with me. We're using our systems of equations to solve for two variables, our x and our y. So, first things first, let's break down the problem. Sarah stands on the ground and sights the top of the steep cliff at a 60-degree angle of elevation. She then steps back 50 meters and sights the top of the cliff at 30 degrees. Sarah is 1.8 meters tall. How tall is the cliff to the nearest meter? So I have two triangles here. I have triangle 1 from A to B to C with sides of x and y. I have the 60. The y is adjacent to the 60. The x is opposite the 60. So I can write an equation for my blue triangle such that the tangent of 60 is equal to my opposite of x divided by my adjacent of y, which I can then rewrite, multiply both sides by y times the tangent of 60 is equal to x. I also have the red triangle from A to B to D that's formed after Sarah steps back 50 meters. This triangle would be of the equation the tangent of 30 is equal to still that same x divided by 50 plus y. We can then rewrite this one, multiply both sides by 50 plus y. We get 50 plus y times the tangent of 30 is equal to x. Note that now both my blue equation and my red equation are equal to x, which means then that I can combine them. I can set these equations equal to each other. So that's what I'm going to do. Y times the tangent of 60 is equal to, parentheses, 50 plus y times the tangent of 30. I'm now going to distribute this tan 30 into this parentheses, onto that 50 and onto that y. So I still have my y tan 60 on the left, but that's now equal to 50 times the tangent of 30 plus y times the tangent of 30. And I want to get both of my y values on the same side of my equation. Therefore, I'm going to subtract both sides by my y tan 30 to get everything on the same side. Now I have y tan 60 minus y tan 30 is equal to 50 tan 30. Note that on my left side, I have two y's on my left, which means that I can now factor them out, such that I can now rewrite the left side as y times the tangent of 60 minus the tangent of 30 is equal to 50 times the tangent of 30. I'm now going to divide both sides by this set, this tangent of 60 minus tangent of 30. Let's see, color I haven't used yet. Have to be green. Y is equal to 50 tangent of 30 divided by tangent of 60 minus tangent of 30, which will approximate to about, where did that go? Approximate to 25. So y equals 25. If y equals 25, I can now plug that back into my blue equation that was y tangent of 60 equals x, such that 25 times the tangent of 60 equals x. Plug that into my Desmos calculator, and I'll get approximately 43.3 meters. Now I want to find the full height of this cliff. The full height is going to be my height, or Sarah's height in this case, of 1.8 plus my x value of 43.3 to give me about 45.1 meters. If you get your answer between 44 and 46, you're good. Depending on where you rounded, will determine what you end up with there. Note, folks, that I did not do any sort of calculations until the very end. But if you wanted to, you could solve for your tan 30 early, your tan 60 early, and round those off. I chose not to. All right, next problem. Balloon. The angle of depression from a hot air balloon to a person on the ground is 36 degrees. Person steps back 10 feet. The new angle of depression is 25. The person is 6 feet tall. How far off the ground is the hot air balloon? So again, we have two triangles, our ABC triangle and our ABD triangle. We're going to follow the same rules to write our equations. The tangent of 36 degrees is equal to my opposite of x divided by my adjacent of y, which I can rewrite as y times the tangent of 36 is equal to x. In turn, my red equation, I have the tangent of 25 degrees is equal to my opposite of x divided by my 10 plus y, my new adjacent, which I can rewrite as 10 plus y times the tangent of 25 kind of my shorthand there, sorry, is equal to my x. Since they're both equal to x, I can set them equal to each other, such that y times the tangent of 36 is equal to, parentheses, 10 plus y times the tangent of 25. I'm then going to distribute that tangent of 25 into this parentheses to give me y times the tangent of 36 is equal to 10 times the tangent of 25 plus y times the tangent of 25. I want to move both my y's to the left side of my equation, so I'm going to subtract y tan 25 from both sides. So I get y tan 36 minus y tan 25 is equal to 10 tan 25. I have a pair of y's on my left side that I'm going to factor out. So y times the tangent of 36 minus my tangent of 25 is still equal to my 10 tangent of 25. Color I haven't used, green. Divide both sides by tangent of 35 minus tangent of 25. Y is equal to 10 times the tangent of 25 divided by the tangent of 36 minus the tangent of 25, which should give me to 17.91. We're going to round that up to about 18. So y is equal to 18. If y is equal to 18, we can plug that back into our blue equation, or the red one if you prefer, such that my blue equation was y times the tangent of 36 equals x. Plug that 18 in for that y. We'll end up with 18 times the tangent of 36 equals x, to give an x about 13 feet. And that's going to be for our value there. We want the full height, so it's going to be the person's height of 6 feet, plus the 13 feet for the x, to give me about 19 feet. And again, depending on where you're rounded, you might get like 18.8 or you might get 19.1, but you're going to be looking for values around 19. And that, folks, are the worked out problems for today's exercises. If you have questions, please ask, but overall, this is just solving for variables, algebra. But if you have questions, please, please, please ask.